Okay guys, Mr. Phil here with Math Made Easy, and today we're going to talk about what I think is a simple topic, but something that's really easy to get confused when working in geometry, and that's the Pythagorean Theorem. So I think a lot of geometry students have heard of it, probably a lot of non-geometry students have heard of it too. So there's a couple terms and things I want to go over, but this is actually a very simple topic if you know what to look for. So let's jump right into it. The Pythagorean Theorem, what does it do? Well, the Pythagorean theorem is a way that we can solve, if you look at this triangle that I drew on the bottom right, it's a way that we can figure out what the side lengths are of a triangle, and that's it. That's basically all the Pythagorean theorem does, is it helps us solve for all three side lengths of a triangle. Now, there's a couple conditions that we need for this to happen, though, or for this formula to work. The first one up here that I mentioned is we absolutely have to have a right triangle when we are doing this, which means we have to have a triangle with one 90-degree angle in it. So if you look at the triangle I drew in the bottom here, this box here in the bottom corner, that tells you that this angle in here, I'll circle it, is a 90-degree angle. So of course we don't have a protractor, or we're not going to measure every angle. So when you come across a problem with a triangle like this and you think, oh, I might be able to use the Pythagorean theorem, either in the given or in the problem, they must tell you that this triangle is a right triangle, or you must have this box in the corner to signify a 90-degree angle. Otherwise, you can never assume that an angle is 90 degrees or that two angles are congruent or similar just because they look like it. In geometry and in math, everything is exact, so they have to tell us, hey, this is a right triangle. That immediately should tell us, okay, well, we can use the Pythagorean theorem if we have a couple other pieces of information. So, the other main pieces of information you need are this. You need to understand what the hypotenuse is and how to locate it, because that's going to be important in understanding how to solve this formula here on line number 3. So what is the hypotenuse? Well, the hypotenuse of a triangle is just the longest side. So how do you locate the hypotenuse, or how can you tell? Well, the hypotenuse is always going to be located opposite or across from the largest angle. That's just how shapes work. The side lengths are directly proportionate to the opposite angles to which they're attached to the line segments or the sides of the polygon. So for a triangle, and we have a right triangle, to be specific, the hypotenuse, thankfully, is always going to be just across from the 90-degree angle. So if you can locate the 90-degree angle like I did here and circled it in green, you can see I drew a purple arrow to the opposite side, and that side is the hypotenuse. And in the equation, or the Pythagorean theorem, C represents the hypotenuse. So the reason why it's important to understand what the hypotenuse is and locate it is because that's a very vital part of our equation. Now, when we go to do the rest of it, it doesn't matter for A and B which side you choose for each letter. This could be A, this could be B, or let's do a different color. How about in red? This could be A, this side could be A, and this side could be B. It doesn't really matter. All that matters is the C. Once we've understood those points, then we can start to solve. So let's start with an easy problem. If side is 3, or I'll erase some of these letters just to clear things up. So I'll go ahead and write some number values so you can actually figure it out and see how to use the equation now. So let's just do a nice and easy problem. 3, 4. Okay? So how are we going to plug this into our Pythagorean theorem now? We're going to understand that these side lengths, then 3 and 4, are the shorter legs, and that this side opposite the 90-degree angle is the hypotenuse. So I'm going to plug 3 and 4 for A and B. And like I said, it doesn't matter. I'm going to do 3 squared plus 4 squared and just to show you that it doesn't matter if I write those parentheses or not, especially for positive numbers, we're going to solve, okay? So we got to evaluate these expressions. Not 3 to the second power, 3 squared is 9. 4 to the second power is 16. And then we have c squared. So to solve for that, which equals 25. To solve for that, I'm going to choose a different ink. I'm going to use a lighter blue. So to solve for this problem here, c squared equals 25, what we need to do is take the square root of both sides. So all the way over here, I'm going to write it. The square root of c squared and the square root of 25. And then remember, when we are taking the square root of both, or a number, an integer, we're going to, or any number, we're going to take the positive and negative values with it. But in geometry, because it is impossible to have a side length of -5, we're just going to say the answer for this is 5. And that's it. That's all you have to do for the Pythagorean theorem. There are a couple other interesting things that come in with certain types of triangles with certain angle measures, namely a 30, 60, 90 degree triangle or 45, 45, 90 degree triangle. But what you need to understand in these specific reference triangles are all just to help us solve for the side lengths of a triangle. It's just because we have these certain proportions that we can set up and scale factors that allow us to do this. So with the Pythagorean theorem, it's the same thing. All we're doing is we need to find the side lengths of this triangle. So we have an equation that allows us to do this if and only if we have some very specific conditions. You need to have a right triangle, and you need to have at least 2 out of the 3 side lengths. That's a big thing. I didn't mention that before, but if you only have one side length and they only gave you one diagram, you need to have a way to find a second side length in order to use the Pythagorean theorem to solve for the third. So they might give you a relation, like they might say, instead of 3, they might say this is like the letter A, and then this is A plus B. So those are still side lengths even though they have variables. So we'll be able to plug those into our equation, but you can see how it's going to become a much more complicated, actually quadratic formula or quadratic equation when we need to solve. So that's the main idea. You have to have 2 out of the 3 sides. It doesn't matter if you have A and B, B and C, or C and A. You just need any 2 of the 3 sides. You need a right triangle, and then you need to be able to locate the hypotenuse, because the hypotenuse is always the part that's by itself. The hypotenuse is always going to be C, and the way you locate the hypotenuse is you find the 90-degree angle based on the box, or if they tell you, and then you go to the side opposite. So just look directly across. That side is C, and that's what you're going to use in the equation. So that's it. Find as many problems as you can do until you figure out how to solve these and you can get quicker at them. It really shouldn't be that difficult, but for a lot of people this is hard to understand, but I think it's because they are not sure what to look for, and they also don't understand the purpose of this and why we use the Pythagorean theorem. So I hope that can clear some things up for you. Take these ideas and tips and put them into practice. I wish you the best of luck, and as always, I am wishing you well. So this is Mr. Phil signing off, and I will talk to you soon. Bye.